So this is the new ViewSonic 27-inch QHD 165Hz VA1MS FreeSync gaming display, and the new Western Digital SN770 2TB NVMe M.2 SSD, and the new Western Digital Blue 4TB desktop hard drive. Okay, yeah, go. Rewind it. Okay, I have 3 parts today, so let's go through them one by one. ViewSonic is a display brand, founded in 1987 and well known for their colorful, vibrant, and affordable display solutions. 27-inch describes the size of the monitor, specifically the diagonal of the screen. QHD is the resolution, and stands for Quad High Definition, offering 3.7 million pixels to be displayed. 165Hz measures the refresh rate, or how fast the display can switch frames per second. 1ms states the response time, in milliseconds, or how quickly the monitor can show the next frame that the computer sends out. FreeSync is a syncing technology that allows the computer and monitor to cooperate to their fullest extent, aligning the frames between both devices and reducing screen tearing. And a gaming display is, well, a display used for gaming. Moving on to the SSD and HDD, Western Digital is a brand of computer storage known for their reliability and affordability. SN770 is the model number of the SSD and is used to track specifications, while Blue is the line of robust hard drives that have worked for years. NVMe M.2 states the data transfer protocol, as well as the port used on the motherboard to install these drives. The hard drive uses the SATA transfer protocol and port. 2TB and 4TB is the capacity of the drive, in bytes. SSD stands for solid state drive, while HDD stands for hard disk drive. I will be going more over the monitor, but if you want to learn more about drives, check out the video linked above. So real quick, let's review drives before I talk about the new monitor. A drive is a form of media storage that interfaces with a computer. They usually come in the form of HDDs or SSDs. A hard disk drive, or HDD, is a drive that stores data magnetically on metal platters. A read-write head moves back and forth while the platters spin at a set revolutions per minute to read data. A solid-state drive, or SSD, is a newer type of drive that stores data electronically using flash memory. This allows for faster access because there is no need to read the metal and translate it into electronic data because it's already electronic. So you can understand how SSDs are faster but can be more expensive. If you want some more in-depth information, I'll leave a dedicated video down in the description. So here we go. A monitor is one of the more essential pieces to a computer setup. However, it is not necessary to a computer's operation, but is an essential part to user input. So for this reason, we call it a peripheral device. A mouse and keyboard are also peripherals. A monitor is key to user input because it provides the user with a visual interface and allows you to see what you're doing. Historically, it is the first peripheral device to be used, dating back before mice and even keyboards. When buying a monitor, there are many core features to choose from: size, resolution, refresh rate, display inputs, response time, and panel type. Then there are some optional features: adaptive sync, contrast ratio, HDR, curvature, and onboard I/O. The size of the monitor is exactly how it sounds. Every monitor will state its size in inches. But wait, a monitor is 3 dimensions. How can you determine size from one measurement? Well, monitor sizes measure the diagonal of the screen. This size combined with the aspect ratio, which is usually 16:9, can give you the dimensions of the screen. Additionally, most manufacturers provide the absolute dimensions of the entire monitor. My monitor has a 27-inch screen. The resolution of the monitor is determined in pixels and is always shown with the monitor specifications. Common resolutions include 1280 by 720 or HD, high definition, 1920 by 1080 or FHD, which is full HD, 2560 by 1440 or QHD, which is quad HD, 3840 by 2160 or 4K UHD or Ultra HD, and 7680 by 4320 or 8K UHD, which is also Ultra HD. My monitor has a QHD resolution. The refresh rate of the monitor is computed by how many images the monitor can produce in a second, hence the units of hertz, or cycles per second. Common refresh rates include 60 Hz, 120 Hz, 144 Hz, 240 Hz, and 360 Hz. Higher refresh rates can display a smoother image, but users prefer a sweet spot, close to 240 Hz. My monitor is 165 Hz. Display cables have multiple port types. These come in a variety of shapes and sizes. Common video ports include HDMI, VGA, DisplayPort, and DVI. Make sure to check that your monitor has these inputs and buy respective cables. HDMI and DisplayPort are also capable of transmitting audio, so your monitor may have built-in speakers as well. Monitors like mine may also come with display cables, so look out for that. My monitor has 2 HDMI inputs and 1 DisplayPort input, while also coming with a DisplayPort cable. Response time is also simple. It states how fast the monitor will respond to video signal from the computer. This should generally be low, leading to less input lag and a faster experience. The most common response time today is 1 millisecond, which is what my monitor also has. This is a subtle feature that everyone should check first. There are 3 common types of panels: TN, IPS, and VA. TN, or twisted nematic, twists the liquid crystals inside the LCD display and warps light to show black or white. This was the first major mobile LCD technology, but is long outdated due to its color inconsistency from different viewing angles. IPS, or in-plane switching, is very similar to TN, but the anatomy of the electronics is slightly different. This fixed TN's viewing angle problem, but lowered the contrast ratio and was more expensive. VA, or vertical alignment, is very similar to IPS, but the liquid crystals naturally align vertically, so more control can be placed upon each pixel in terms of brightness. This leads to higher contrast ratios, but brought back the viewing angle issue from the TN panel. IPS panels are widely desired by many laptop users, since viewing angles can vary drastically. However, VA is widely used by desktop users, since they have better color depth and the angles stay relatively straight. My monitor has a VA panel type. Moving on to some optional features, we have a technology called adaptive sync, and this one is a bit hefty. The purpose behind this is to fix one main issue with previous displays. Older displays had fixed frame rates, and the computer supplied frames to the display at that frame rate. However, when confusion happened within the computer and it did not supply a frame in time, the monitor would keep the previous frame until it received a new one, or in some cases, the monitor would attempt to display the completed frame and fail, resulting in half a complete frame and half a previous frame. This is problematic for the user as it leads to an inconsistent viewing experience filled with stutter and tear. Adaptive sync fixes these problems by syncing the frame rate of the monitor with the computer, letting them communicate and work out when the next frame should be displayed. My monitor comes with AMD's FreeSync Premium. The contrast ratio is simple. How bright or dark can the monitor get? It's defined as the ratio of the brightest white to the darkest black. A higher contrast ratio is preferred, as it means the monitor will have a higher color depth and can show more vibrant colors. My monitor has a ratio of 400 million to 1. HDR, or High Dynamic Range, is a display technique designed to increase color depth by modifying the color space of the display itself. Most displays use 8-bit color, utilizing 8 bits for each color of each pixel on screen, allowing for a total of 16.777 million colors. The most common form of HDR raises this from 8-bit to 10-bit color, allowing for a total of 1.074 billion colors. It is generally preferred to have HDR, but it is quite an expensive feature. Some monitors can be curved. You have most likely seen this with earlier TVs, and the same technology has arrived in monitors. A monitor's curvature is measured by its radius in millimeters. Curvature comes with a few benefits, namely comfortability, but it also looks pretty cool. My monitor has a 1500R curvature, meaning its curve has a radius of 1500 millimeters. A quick calculation shows that it comprises 22.8 degrees of the equivalent circle. Some monitors include onboard I/O, which can include USB or audio ports. USB can be useful if your computer is too far away and you need to plug in devices, and audio can be useful for the same reason. They can also provide backup solutions in case your main ports fail. My monitor comes with a headphone/mic combo jack. That's all on a monitor, so make sure you look for the things that you want and purchase the one that's right for you. This is becoming a bit of a trend, but a monitor is also one of the more customizable peripherals for a computer, since many manufacturers produce monitors with the features that you can pick and choose, so you can assess the price afterwards. Now, unlike an internal component of a computer, a monitor can be installed very easily. No removing the graphics card, no unscrewing anything, and no opening any side panels. We don't have any preliminary work to do, so on to unboxing. This monitor comes with the monitor, of course, the disassembled stand, the power supply in 2 parts, and a DisplayPort cable. Next, we have some assembly required. Most monitors with stands do come disassembled, so let's put it together. Mine requires a single screw, as well as the thumb screw at the bottom. Now we can seat the monitor on my desk. Take very special care not to put pressure on the display, as this can easily crack the screen. Additionally, the plastic front may never show signs of abuse, but the screen underneath may be damaged. Make sure to power it on as soon as possible to ensure that it is fully functional. Next, I have 2 cables to plug in. First, let's plug in power. This power supply comes in 2 pieces, the wall plug and the adapter and 12-volt DC jack. First, insert into the wall plug and connect the adapter, resting it on something stable so it won't fall over and possibly hurt the cable. Then pull the DC jack on top of my desk and plug it into the monitor. Next, let's plug in the DisplayPort cable. First, plug the cable into the computer at the back. Make sure to plug it into a dedicated graphics card if you have one. Then pull it up to the desk and plug it into the monitor. Turn the computer and monitor on, and you should see your brand new monitor spark to life. Hopefully it doesn't actually spark. Now I'll be carrying out the storage upgrade, which is very similar to the one I performed 3 years ago. I'll be installing a brand new 2TB M.2 SSD and a new 4TB hard disk drive. First, I'll shut down the computer and unplug all cables. This is standard for any component change, as you've probably noticed. Then I'll unscrew the 4 thumb screws on the side glass window and slowly remove that. Stow this somewhere safe so it won't get damaged during the installation process. Next, we need to expose the M.2 slot on the motherboard, so we need to remove the graphics card. Unscrew the mounting screws at the rear of the case. Disengage the PCIe lock, unplug any PCIe power connectors, and slowly pull the card out of the slot and then set it aside. I'll clean that up a bit later. Now that both of our M.2 slots are available to us, we can install the SSD. For some hierarchy, I'll be installing the new SSD in the M.2 1 slot and moving my existing SSD to the M.2 2 slot. This allows me to take full advantage of the PCIe 4.0 speeds that the new SSD can run at. First, unscrew the existing SSD out of the standoff, and then slowly pull up and slide it out of the slot. Now, insert the new SSD into the slot at an angle, then slowly push down and secure it with the screw. To finish up, install the second M.2 standoff into the M.2 2 slot for 2280 sized SSDs. Then unscrew the screw and grab the existing SSD. Insert this existing SSD into the slot at an angle, then slowly push down and secure it with the screw. Now that the SSDs are successfully installed, we'll move on to the hard drive situation. I currently have two 1TB hard drives, which we'll call G and H. I'll be swapping one with the new hard drive and formatting the other. Now, since I'll be swapping a drive and need the data from the old drive, I need to mind my connections. First, unscrew the thumb screws on the other side panel of the case and remove it. Stash this somewhere safe as well. Next, pull the second drive bay out of the case. Line up the new hard drive and snap it in, then secure it with the 4 screws provided. Now that all 3 drives are mounted, I'll swap the connectors from the G drive to the new drive so that I can start transferring data from the H drive. Once the transfer is complete, I can disconnect the H drive and unmount it from the system. Disconnect the SATA power and data cables, unscrew the 4 mounting screws, and slowly remove the drive. I'll be e-recycling this drive to make sure my data is erased. Now, all that's left is reassembly. First, reinsert the drive bays, putting the new heavier drive on the bottom with the lighter G drive on top. Then secure the connections for both drives and tidy up any cables. Then close the side panel on this side and fasten the thumb screws. Now we can reinstall the graphics card. Insert the card into the PCIe X16 slot on the motherboard and slowly push down until the locking lever clicks into place. Then, fasten it back to the case using the 2 screws provided. Finally, place the glass side panel onto the rubber posts and screw the 4 thumb screws back on. Now that the hardware upgrade is complete, we can move on to software. For anyone else making a similar upgrade, I'll be reinstalling Windows 10 Pro to the new SSD and formatting both the existing SSD and the G drive. Formatting freshens a drive to be used by an OS, and thus erases all data stored, so make sure you have either a complete backup or at least a copy of any relevant data. I'll also be reinstalling Linux Mint onto my 50GB partition on the existing SSD, as well as reinstalling any programs and games that I want to keep on different drives depending on size. For example, many of my large single-player games and programs will be put onto the larger hard drive, and any smaller programs or multiplayer games that I use more often will be installed on the SSD. After all the installations are complete, we can finally experience the full boot up. So with these upgrades to the computer, how can you or I tell what changed? Well, in this video there were 2 main upgrades, the monitor and the storage. So let's go over them one at a time. Regarding the monitor, the biggest change would be the resolution, going from 1080p to 1440p. However, the more noticeable change in my opinion was the refresh rate, going from 60Hz to 165Hz. Movement on the screen is much smoother and more fluid. Other miscellaneous features like HDR, FreeSync, and a VA panel also provide improvements to the quality of the display. Regarding the drives, I upgraded my boot drive from PCIe 3.0 to PCIe 4.0, so a slight improvement to boot times there. But I also quintupled my SSD storage, so I can fit more programs and games on it. In addition, I also added 3 TB of hard drive space, so lots more space for archival files such as Blender cache or video renders. I hope you enjoyed this video. It was certainly a blast for me to make and put together. If you want to see any more of these videos, subscribe below and tap the like button. Thank you all so much for watching, stay safe and have fun.